For generations, scientists have obsessed over one cosmic mystery above all others. Not just whether worlds orbit distant suns, but whether there are planets literally next door, so close in galactic terms that we could hope to reach them in our lifetimes. The Alpha Centauri system, radiant and inviting, has long felt like the universe's biggest almost. Its stars are close, familiar, yet frustratingly reticent, echoing with possibilities just beyond our grasp. Every technological leap brought fresh hope. Every mission, every clever analysis, every new telescope aimed its way. Yet, Alpha Centauri always managed to slip away, its overwhelming brilliance blinding our detectors, its binary dance scrambling our signals. For half a century, this close companion has been a riddle, alternately tempting and tormenting astronomers, haunting our dreams of interstellar discovery.
All that seemed poised to change with the arrival of the James Webb Space Telescope. In a bold move, its hypersensitive gaze was turned not to quiet distant galaxies, but toward the blinding spotlight of a nearby star system. Webb was designed for the edge of the observable cosmos, not for the perilous glare of Alpha Centauri. Scientists pushed the telescope's capabilities to their edge, rewriting rules for data reduction and detection. What they found wasn't the reassuring clarity of a benign neighbor, but a surge of ambiguity, the fleeting glimpse of a planet. Then, the void. Webb didn't so much pierce the veil as lift it, only to reveal deeper, more unnerving mysteries. Suddenly, proximity felt less like an advantage and more like a confrontation.
In August 2024, expectations were modest. Decades of failed observations had made astronomers wary, even cynical about Alpha Centauri. Webb's engineers developed new calibration routines to wrestle with the glare and shifting field, knowing this system had forced clever instruments to the breaking point before. After marathon observing sessions and months spent dissecting every pixel, a faint, undeniable source of light materialized, S1, a candidate planet orbiting at about 2 astronomical units from Alpha Centauri A. Its appearance was unambiguous, stronger than almost any previous exoplanet detection, so close to home. Statistical significance reached a confidence level that made mere noise exceedingly unlikely, and the initial result survived an onslaught of skeptical testing. Was this finally the proof astronomers had been waiting for?
Exhaustive cross-checking followed. Background stars matched with Gaia catalogs, galaxies ruled out by their spectra and motion, slow-moving objects within our solar system eliminated by precise tracking. Even advanced injection and recovery tests designed to simulate false positives could not dismiss the signal. The data held up. S1 appeared consistently across independent datasets, a faint but persistent signature carved from the chaos. For the first time, the claim of a planet in our closest solar twin's orbit carried the weight of measurable proof. Enthusiasm was matched by nervous disbelief. Was it finally real?
Any exoplanet discovery demands confirmation, especially one so consequential. The Webb team scheduled further observations for February and April 2025, planning to repeat the detection with identical methods, this time capturing any orbital drift that would reveal S1's path. The system was watched with unwavering attention, the data stacked and sifted again. And yet, the planet had vanished. Where there had been signal, now there was only noise, the region empty, devoid of even the weakest echo. This confounded even seasoned researchers. Planets do not evaporate, their gravitational anchor prevents such disappearances. Was it a monumental statistical outlier? Had some as-yet uncatalogued background object spoofed Webb's detectors? Or, most provocative of all, was this the first taste of a truly exotic orbit? Further analysis uncovered something remarkable. Orbital simulations suggested a high proportion of viable orbits could naturally produce such now you see it, now you don't outcomes. If S1's path was highly eccentric or steeply inclined, there would be long windows where even our most advanced instrumentation would miss it entirely, especially around the glaring light of its host star. Rather than disproving existence, the planet's weather-like disappearance supported a new model: persistence, hidden in the dark.
Alpha Centauri's closeness once seemed guaranteed to make discovery easy. At only 4.37 light-years, its leading star nearly a mirror of our Sun's mass, luminosity, and longevity. Astronomers fantasized about finding a planetary system akin to our own, maybe even a twin Earth drop that foiled long-term observation. Every null result chipped away at hope, and alternative explanations grew. Maybe planets were rare or absent due to the twins' gravitational disruption. Or maybe they danced in bizarre, elusive orbits our techniques couldn't detect. As technology advanced, so did skepticism. Observers realized that Alpha Centauri was not a gentle laboratory, but a battlefield where competing gravities and shifting light created a perfect storm. Instruments designed for calm, distant targets were confounded by its proximity and brilliance. Alpha Centauri, once the most approachable system, became the most enigmatic, close but elusive, simple only at a glance, and a constant challenge to the arrogance of assumption.
The S1 candidate, by its estimated placement, occupies a notoriously hazardous zone. 2 astronomical units from Alpha Centauri A, prime real estate, but also deadly, wedged into the realm where Alpha Centauri B's tidal pull is strongest. Planet formation models decreed that orbits there should be chaotic, afflicted by gravitational tugs hard enough to eject worlds or break them apart over eons. This was not a place for peaceful planetary development. Yet, S1 emerged precisely where models claimed stability was least likely. How could it persist? Only in the most unusual orbital configurations. Long, elliptical paths, deeply tilted, launching the planet into safe distances for much of its orbit, but bringing it perilously close on rare, brief passes. Such worlds wouldn't appear in every snapshot. They would flicker in and out of visibility, challenging expectations, and vanishing from coronagraphic views more often than not. Invisibility, not presence, would be the mark of their survival, defiant, eccentric, and hidden.
But surviving is one feat. Forming in such a place is another. The hostile gravitational landscape early in Alpha Centauri's history would have been even more violent, with the binary companions stirring the protoplanetary disk into a frothing chaos. Tiny dust grains, the seeds of planets, would have struggled to cling together. Collisions would be fast and fragmenting, discouraging the slow and gentle accumulation that classic planet building requires. That S1 exists argues for scenarios outside normal models. Perhaps it was born close to the star and cast outward, or maybe it came together in some forgotten niche, missed by current theory. Either way, its very existence calls into question frameworks that have explained thousands of other systems. This is more than an oddball world. It's a stress test for planetary theory, a crack in the cosmic scaffolding scientists use to predict where other worlds should grow. S1 hints that nature might be more creative or more forgiving than we realized, finding ways to build planets under circumstances we once thought impossible.
The James Webb Space Telescope was engineered to see the universe's faintest glimmers, not the searing glare of bright, close stars. Focusing Webb on Alpha Centauri was a daring risk, an exercise in pushing technology past its safe limits. Webb's precision, so reliable for ancient galaxies and far-flung nebulae, buckled under the intensity of Alpha Centauri's shine. Only the most advanced, tailored data reduction, custom software, and manual recalibration could tease out the faint signal of S1. Even then, non-detections in later sessions spoke less to the planet's absence and more to Webb's own blind spots, zones of sensitivity shaped by the complex optical setup. This experiment did more than suggest a discovery. It revealed the fragile edge of even our greatest telescopic power. In the case of S1, the difference between proof and mystery came down to the quirks of hardware, the timing of orbits, and the lottery of angles, not just the rules of physics.
future attempts at similar feats will mean constant trade-offs, pushing instruments to their breaking point, and embracing the possibility that sometimes the universe hides its greatest answers in plain sight, just beyond the reach of even our boldest inventions.
The detection of S1, gas giant or otherwise, is not just a curiosity, it is a paradigm shift. Such worlds, even if inhospitable themselves, can shepherd moons. Our own solar system's most promising environments for life are icy satellites around giants like Jupiter and Saturn. If Alpha Centauri A truly hosts its own gas giant, then a retinue of moons, perhaps harboring atmospheres or even subsurface oceans, becomes plausible. Suddenly, our nearest star system transforms from an abstraction to a concrete place, ripe for future telescopic or even exploratory missions. But this proximity brings discomfort as well as hope. Alpha Centauri was always thought of as an ultimate goal, a system theoretically within technological reach, given ambition and time. The possibility that it hosts hidden and possibly habitable environments shrinks the metaphysical distance between Earth and somewhere else. No longer is the mystery comfortably remote, it is personal, immediate, and profoundly destabilizing. Webb's efforts didn't simply raise new scientific questions, they forced us to consider the full implications of a cosmic neighborhood alive with possibility, yet just out of definitive sight. In the end, James Webb didn't offer closure. It gave us a proximity fraught with uncertainty, and a star system that became not simple and safe, but elusive and layered. We're forced to admit that what is nearest may also be what is least understood. Sometimes the universe's greatest secrets are the ones waiting right next door, brilliant, blinding, hauntingly close, and forever daring us to look deeper.